All right, in this lab, we are going to look at the chemical reactions of three different metals. First, as they react with water, and next, as they react with hydrochloric acid. So first, let's look at the reactions with water. Now, before we test the metals with water, I want to look at a way that we're going to see whether or not a reaction has occurred. We're going to use red litmus paper, and we're going to observe whether or not a color change occurs on the red litmus paper. So first, as a control, let's look at what happens when we dip red litmus paper in plain water. So I've added some water to this well. We'll dip the piece of red litmus paper in. And no change, as we should hopefully have expected. All right, in this first test, we're going to look at calcium and magnesium. We're comparing these two because they share a group on the periodic table. And I'm just going to put a few drops of water from this water bottle into each well, and we'll see what happens. And as you can see, and hear as well, the calcium reacts quite vigorously with water. Magnesium doesn't seem to be doing much of anything. I'm going to go ahead and put my red litmus paper into each. I might not have enough liquid left in here to saturate the litmus paper. I'm going to add a little bit more liquid to the calcium well. And as we see here, the red litmus paper has turned quite blue for the calcium reaction. For magnesium, it's starting to turn blue down at the very, very bottom, although that could just be because some of the mixture from the calcium jumped across the well into the magnesium well. Now, if I were filling out my data table, for the magnesium, it seems as though there's no apparent reaction. As I look very closely at it, it's possible that there are some bubbles forming. For the calcium, I would write for my observations vigorous bubbling, steam was produced, the whole mixture turned white. It started out looking like a normal gray silvery metal and now looks white and kind of flaky. In terms of the litmus test, it seems that the magnesium stayed red and the calcium turned very clearly blue. Now we're going to do the same test with aluminum. So over here I have a little crumple of aluminum foil, and I'm going to add some water to that well. Let's wait a minute to give it some time to react, see if it's going to do anything. We have aluminum in this test because aluminum is in the same period as magnesium. So in this comparison, we're comparing two things in the same group, and in this comparison, we're comparing two things in the same period. From the vantage point of this camera, you may not be able to tell, but the aluminum foil appears to be floating. There's really not much going on. I don't see bubbles or anything. I'll put my litmus paper in there. The litmus paper has become saturated. It looks about the same as the control that I tested with plain water. So I see pretty much nothing going on with the litmus paper there. All right. So in my observations for the aluminum, I'm going to say no reaction, aluminum floats. The litmus test stays red. Now, the other test that I want to do, I want to compare the reactions of each of these three things with hydrochloric acid. So I have a fresh set of wells. Here's my piece of calcium. I'll hold this up a little bit closer so we can see it. Standard kind of grayish metal. My little turnings of magnesium. Again, standard kind of grayish metal. And then a crumple of aluminum foil, which looks like, well, crumpled up aluminum foil. Now, we're going to test the reaction of these with hydrochloric acid. The other thing that I want to do with these, so we can't use litmus with this because the acid will turn litmus red. So because there's acid, it will always stay red. So instead, we're going to observe the reaction or the progress of the reaction by monitoring the temperature on this thermometer. So let's see. Our initial temperature looks like 24.6 degrees Celsius. I'm going to go ahead and do the aluminum reaction first. I'll add my hydrochloric acid. And let's wait a minute or so and see what kind of reaction we observe, both in terms of the observations of the aluminum in the well as well as the temperature. Temperature has risen. It's at 24.7. I don't know that that's appreciably different from what it was before. And I'm not really seeing any physical evidence of a reaction in the well. Nope, we're back to 24.56. So it seems like so far nothing is really happening here. All right. So next, let's test the reaction of magnesium with the hydrochloric acid. And again, let's just re-standardize ourselves. Our baseline temperature of the hydrochloric acid in its own well. And this is now indicating something around 24.4 degrees Celsius. Now let's see what happens over here. This is reacting relatively vigorously now. Lots of small little bubbles being produced. Looks like a little bit of steam of some sort. Our temperature has climbed to, what is that, about 35? I think it hit 37 degrees, although the temperature is dropping again. Looks like maybe the reaction is largely finished. So it climbed very rapidly, and now the temperature is dropping again very rapidly. And it's back down to almost 30 degrees. So what I would record in my data table for the final temperature of the magnesium with hydrochloric acid is whatever that maximum temperature was. I realize that it's coming to rest now, back down near where it started. That's simply because the energy is dissipating. But what I would record there is the highest temperature reached. And if we look at what's happening in the well, the reaction looks to be pretty close to complete. There's still some little bits of steam, some bubbles being produced. Let's see, if I put some more hydrochloric acid in, we should be able to see if it kicks up again. There it goes again. And now the temperature is rising again. 29, 30, 31. So this seems to react pretty readily with the hydrochloric acid. And lastly, let's test the reaction of calcium with the hydrochloric acid. So I'm going to check my baseline temperature again. I think my thermometer is a little bit warmer than the hydrochloric acid is, just because it was in that warm well. Looks like our baseline is somewhere around 25 degrees right now. Okay, so that's our initial temperature, and let's see what our final temperature ends up with this one. That's really going. Lots of big bubbles being produced, lots of steam. Our temperature's at 77 degrees right now, 78. Coming back down again, but it looked like it got up into the high 78 degrees. Oh, I think it just hit 80. '83. So this is reacting quite vigorously. Similar to the reaction with water, but perhaps more vigorously. I'm adding more hydrochloric acid so we can keep watching this nice vigorous reaction happening. So, if I were writing observations, if I were to compare some of these reactions, I would say the aluminum seems to react very little, if at all. Now, after several minutes, there might be a few tiny little bubbles on there, but doesn't seem like much. The magnesium reacts pretty readily, lots of small bubbles, but the reaction seems to finish quickly and then settle back down. And the calcium, man, this just goes. There's a little piece of calcium in there that's kind of bouncing around with all the bubbles it's producing. And it makes this kind of dense white substance as a product. Lots of steam being produced with the calcium. All right, so there we have our three different reactions, first with water and then with hydrochloric acid. And from those three different reactions of each metal, we should be able to draw some conclusions as to the trends of metal reactivity based on their location within the periodic table.